Okay, now let's talk about developing a Siamese network for UTIs risk prediction in mobile patients undergoing stroke. And this is Zhu Xu from Peking Union Medical College in Beijing, China. First, let's learn some key facts about stroke. We all know that stroke has become the top 3 leading causes of death in China. It has an increasingly high prevalence and incidence, and over 12 and 4.42 million patients aged over 40 years old. Also, it has led to a large burden of disease due to the high risk of disability and mortality. And the figure 1 and figure 2 shows the prevalence and the mortality of stroke in China from 2005 until 2016 and 17. For stroke patients, they tend to suffer from the cerebral nerve damage, and it means they are more likely to deteriorate into immobility and suffer from relevant complications. This could cause many poor outcomes like prolonged length of stay, increased hospitalization costs, increased risk of mortality, and their renal function would get worse and worse. Therefore, assessing and identifying high-risk groups of UTIs has become an important task for the infection management among the patients undergoing stroke. Here we list some examples of UTIs prediction tools. As we all know that previous work has provided well-documented effects for the risk factors and highly susceptible populations for UTIs, while the risk prediction for UTIs is emerging. And we can see from table 1 that recently the mainstream has transformed from traditional logistic regression models to machine learning approaches. Researchers use these innovative approaches to capture the complex and the nonlinear relationships between variables and outcomes, and it can deal with the imbalanced data. So in this study, we proposed to develop an effective prediction model to identify UTIs risk in immobile stroke patients, and we compare its prediction performance with traditional models and other machine learning models. This study was based on a nationwide investigation covering 25 hospitals throughout China. We enrolled 4,018 patients from 2015 to 2016. The enrolled patients they had a primary diagnosis of stroke at admission, and among them, 3,982 patients were included for further development of prediction model. Specifically, we defined the stroke referring to ICD-10, and the stroke patients in this study were further categorized as hemorrhagic stroke and ischemic stroke according to ICD-10. Also, for patients have both subtypes of stroke mentioned above, we called them mixed cerebrovascular disease for another subtype. And in this study, UTIs were referred to European Association of Urologic Infections guidelines. And a total of 18 features were included based on clinical knowledge and previous work. The extracted features cover the demographics, hospitalization information, medication status, and the disease-related information. And we recorded this information by self-record or assessment and the records from the registered nurses. Also, we set the cutoffs of 1 week and 2 weeks for length of stays, duration of immobility, and length of urethral catheter indwelling. And table 2 shows the whole view of the variables contributing to this model. Importantly, we may notice that the UTIs prevalence in this study was even lower than 3%, and it is definitely an imbalanced data. So in order to solve this problem, we employed a Siamese network. This is a kind of deep neural network containing 2 subnetworks. And it was originally proposed to solve the handwritten digit recognition. Based on similarity calculations, the samples were input pair in pair, and they can, in this method, we can balance and enhance the data. And in this study, the training process, here we listed some applications of Siamese network. You can see that it has been applied into sequence alignment, radio image detection, and many other biomedical fields. In this study, the model was derived in 3 steps. The first is we construct the sample pairs. The SimNet accepts the features vectors of 2 samples as input, and for each sample, we pair it with a positive sample and a negative sample to construct a sample pair and use it as a model input. The second step is to extract the features. The feature extract from the hidden space embedding factors or from the 2 input samples, respectively, by the feature extraction blocks, including 1-dimension convolutionary layer, max pooling layer, and the fully connected layer. And the third step is the classification. As we can see that we concatenate the embedding vector of 2 samples and transfer it as the input for category prediction. And in table 4, we list the parameters for the SimNet. We further examined the performance of SimNet by making comparisons with other models, including linear logistic regression model with or without regularization, random forest, light GVM, CatBoost, and multiple layer perceptron. It has been shown that the SimNet performs better than other models in this study, whatever the sensitivity, specificity, accuracy, AUC, or the precision. Especially, we may notice the improvement in sensitivity because this is clinically meaningful, especially for identifying the outcomes of interest for the minority class, since ability to identify potential high-risk patients is of great interest in this study. And we reflect on these things, and we may conclude that the SimNet performs well in predicting UTIs risk for immobile stroke patients in this study, and the improvement in sensitivity indicates its ability to detect the class of minority, which is of more clinical interests for the disease and complications at a relatively low prevalence, but with destructive outcomes. Also, we may partially contribute attribute this into the pairwise inputs of samples of SimNet, because this can contribute to a meaningful vector representation during the training procedure and to conduct the classification task easier. We can see in figure 5 that in contrast with training samples space, the embedding factors of SimNet feature extraction block narrows the distance between the UTI samples. Furthermore, the ability to reuse samples in the training set might also help enhance the prediction of the SimNet. And this is all the presentation. For further questions, you may contact me at my email address. And thank you for listening.